For our practice on cycloadditions, I've chosen to focus only on Diels Alder. While we did spend a few minutes discussing a couple of other cycloadditions, Diels Alder is by far the most important of our cycloaddition reactions, and so it's the one I've given you some practice for here. What I would suggest in doing these um, is to start by redrawing any of your dienes that are not, redrawing them in the S-cis conformation. Recall that the S-cis is what we need for a Diels Alder and is when the diene is in that conformation. So for the way that I've drawn most of these, that's going to require rotating about this central bond here. So if I do that in this first case, we end up with the diene looking like that. And while we're doing that, we might as well go through and do that for the rest of these. We can do the same in part C. Here's part D that has the two tert-butyl groups. You may recall that when we actually talked about this specific diene in class, we said that these two large tert-butyl groups, and maybe we should use a different color to highlight there, since that just covered up our blue. These two large tert-butyl groups, will cause a very negative steric interaction, and that diene actually can't adopt that S-cis conformation. Because it can't do that, we get no reaction in this case. And then finally, we can do this one here. To give us that diene. From here, it's just a matter of putting our six-membered rings together. We're not going to concern ourselves with regiochemistry. Yes, I'm aware that some of these can have more than one regiochemical product, but we're just going to draw any of them. We're not going to worry about that selectivity in this set of problems. So we know that Diels Alder will make these two new bonds here, and that single bond between the two double bonds ends up getting converted into a double bond. Same thing in part B. We can draw in, I'll do that in this case, we can draw in our arrows to show the mechanism, our flow of electrons. One thing to keep in mind is if you're doing a Diels Alder reaction and you don't end up with a six-membered ring in your product, you've done something wrong. Again, we can draw our arrows here. Again, same way, we're also not going to worry about stereochemistry in these. And then finally, part E, we're going to end up with the bicyclic ring structure in our product.